Hello everybody, it's Leon here, and today we want to briefly look at the frequency table. And at the end of this video you should be able to complete a frequency table and also identify the features of the frequency table. So let's head straight into it. So we have an example. The example says the table below shows the marks gained by 50 students in a test. So for the marks, we see we have 1 to 5, 6 to 10, 11 to 15. Now we call these the class intervals. So the first interval will be 1 to 5, the second interval will be 6 to 10, and the third interval will be 11 to 15. So we call all of these the class intervals. And the next column, we have the frequency. So the frequency basically tells you the amount of observation that happens in the class interval. So for example, we saw that 23 students gained marks 1 to 5, and 13 students gained marks 6 to 10, and 14 students gained marks 11 to 15. So that is what the frequency tells you. And the next we have the class limits. So the class limits, these are basically the end values of the class interval. So the lower limit and the upper limit would just be the end values. So for example, in the first class interval 1 to 5, the lower limit would of course be 1 and the upper limit would be 5. And for the second one, 6 to 10, the lower limit would be 6 and the upper limit would be 10. And for the third one, the lower limit would be 11 and the upper limit would be 15. And the next we have the class boundaries. Now the class boundaries would be the lowest and highest value that fall into the class interval. Alright, so in CSEC, this is basically found by subtracting 0.5 from the lower limit to find the lower boundary and adding 0.5 to the upper limit to find the upper boundary. So for the first example, if you want to find the lower boundary of this class interval, we just subtract 0.5 from this one. So 1 subtract 0.5, that would give you 0.5 for the lower boundary. And then we add 0.5 to the upper limit. So this would be 5.5. And for the second one, subtract 0.5 from 6, that would give you 5.5. And then we add 0.5 to 10, that would give you 10.5. And for the last one, subtract 0.5 from 11, that would give you 10.5. And we add 0.5 to 15, so that would give you 15.5. Alright, so the next thing you want to find is the midpoint. So the midpoint is basically the middle value in the class interval. Now, if we were to list out the marks for 1 to 5, you know that would be 1, 2, 3, 4, and 5. And we can clearly see the midpoint here is 3. But let's just say we had a large observation and it would not be logical, it wouldn't make sense to list out all of the elements. We can basically find the midpoint by adding the lower boundary and the upper boundary and dividing it by 2. So for the first one, the upper boundary would be 5.5, 5.5 plus 0.5 all divided by 2. So 5.5 plus 0.5, that would give you 6 divided by 2, which is 3. And for the second one, 10.5 plus 5.5, that would give you 16 divided by 2, and that would give you 8. And for the last one, 15.5 plus 10.5, that would give you 26 divided by 2 would give you 13. And that is how we can find the midpoint. And the last feature is the class size or the class width. Now for the class size or class width, let's look at this example 6 to 10. If you were to list all the marks that would fall into 6 to 10, this would be 6, 7, 8, 9, and 10. We can clearly see we have 1, 2, 3, 4, 5 marks. So the class width or the class size would be 5. And once again, if we had a very large interval and it would not be logical to list all of the observation, we use the formula, the upper boundary subtract the lower boundary to find the class size or the class width. So for the second one as well, it's basically 10.5, which is the upper boundary, subtract the lower boundary, which is 5.5, and this will give you a class size or class width of 5 as well.